Module 18.1, Day 1, Tangent Ratio, Content Standard. Understand that by similarity, side ratios in right triangles are properties of the angles in the triangle, leading to definitions of trigonometric ratios for acute angles. Language objective. Explain to a partner how to find the tangent of an angle given the diagram with the given angle, measure, and late lengths. Investigating a ratio in a right triangle. In a given right triangle ABC with a right angle at vertex C, there are three sides. The side adjacent to angle A is the leg that forms one side of angle A. The side opposite of angle A is the leg that does not form a side of angle A. The side that connects the adjacent and opposite side is the hypotenuse. So here we're looking at angle A from here. So this side is adjacent to angle A. And this side here is called the opposite of angle A, and this is the hypotenuse. And this is a right angle. So if I were to draw the same triangle, A, B, and C, and this is a triangle, and if we are to observe from angle B, then this would be the adjacent side to angle B, and this would be the opposite side of angle B, and this is the hypotenuse. And the hypotenuse is always opposite of the right angle. Right? Finding the tangent of an angle. The ratio you calculate in the Explorer section is called the tangent of an angle. The tangent of an acute angle A, written tangent of angle A, is defined as follows. So let's go back to our right triangle. So here we're given our right triangle, angle A, B, and C, and angle C is a right angle. So this is so if we're observing from angle A, so this is adjacent to angle A, and this is opposite of angle A, and this is the hypotenuse. So we see that tangent of angle A is equal to the length of leg opposite of angle A, so that is BC, over the length of leg adjacent to angle A, that is AC. Okay? So let's go through our example 1. Find the tangent of each specific angle. Write each ratio as a fraction and as a decimal round to the nearest hundredths. So here, for example, 1A, we're looking at angle A. So here we're looking at angle A. So this is our adjacent, and this is our opposite. So we see that tangent angle A is opposite over adjacent. So opposite is 18, adjacent is 24, reduced to 3/4, which reduced to 0.75. Okay, and now let's look at angle B. So here we're observing from angle B, so this become our adjacent, and this become our opposite. So then tangent of angle B is, we're looking at the opposite over adjacent. So the opposite of angle B is 24, and adjacent to angle B is 18, in which we do to 4/3, or you can reduce this as a decimal, so it's 1.3 with the bar over 3. Right. Okay, let's go on to number 3. What is the relationship between the ratio of tangent A and tangent of angle B? So the relationship is they are the reciprocal of each other. Okay, so then we can say that tangent of angle A is the same as 1 over tangent of angle B. So they are the reciprocal of each other. Do you believe this relationship will be true for acute angle in other right triangle? The answer is yes, because we're switching the opposite and the adjacent. Okay, now it's your turn. Find the tangent of each specific angle. Write each ratio as a fraction and as a decimal, round to the nearest hundreds. So for example 5, I'll give you guys 1 minute to work it out, and we'll go over the answers. Okay, so we're looking from angle Q. So this is your opposite, and this is your adjacent. So we see that tangent of angle Q is equal to opposite over adjacent, which is equal to 15 over 36. And then you use your calculator to reduce that. So this gives us 0.417. Right? Okay, and then now we're looking from angle R. So the angle R is this angle, so then that's your opposite and that's your adjacent. So tangent of angle R is opposite over adjacent. So which is 36 over 15. And continue using our calculator to reduce it to a decimal. So this gives us 2.4. Alright, okay, now example 2 says find a side length using tangent. When you know the length of a leg of a right triangle and the measure of one of the acute angle, you can use tangent to find the length of the other leg. This is especially useful in real world problems. Okay, now for this one we need you guys to use your calculator. Right, but then before you use your calculator, what I want you to do is that make sure that on your calculator, if you use somewhere on your screen there should be a letter D somewhere or a DEG. Okay, this means that your calculator is in degree mode, right? Or if you are using a TI-84 calculator, somewhere on your screen on top there should be a word degree on your calculator. So in order for us to do the next set of example, we need your calculator to be in degree mode. Okay, so example 2, apply the tangent ratio to find the unknown side. In order to meet safety guideline, a roof contractor determines that she must place the base of her ladder 6 feet away from the house, making an angle of 76 degrees with the ground, to the nearest tenth of a foot. How far does the ground is the eave of the roof? Okay, so here we're looking at angle A, and we're saying that this is 6 feet. So then this is the adjacent, and this is your opposite. So we see that tangent of angle A is equal to opposite over adjacent. So then instead of angle A, we change that to 76 degrees over opposite is the distance from C to B, and adjacent we're given this is 6. So then to solve for B, this is 6 times tangent of 76 degrees equal to distance from C to B. So this 6. Okay, and then so then use your calculator to find tangent of 76 degrees. So then you would type in tangent on your calculator and type in the number 76, and then close the parenthesis and press enter or equal. So this gives us 4.0108 equal to CB. And then from there, use your calculator again to find the product. So this gives us 24.9 0.06, and this is in terms of feet equal to from C to B. Right? Okay. So then, in order for this to work, make sure that on your calculator there's a D or there's an DEG on your screen in order for this to work. Okay. And so then we went through step 3 already. So let's continue. Right. Okay. So here, example B. Right triangle STU. What is the length of the leg adjacent to angle S? So here we're observing from angle S. So this is our adjacent. That's the opposite. So we say that tangent of angle S is equal to opposite over adjacent. Right? So then our opposite is given as 87, and the adjacent is SU. So then we're given the tangent, the angle S is 54 degrees, so we change this to tangent of 54 degree is equal to 87 over SU. So then to solve it, we have to use the cross product. So then SU is equal to 87 divided by tangent of 54 degree. Okay, and then from there we can use our calculator to do this. So the step on your calculator is this: you do 87, divide, type in the tangent, parenthesis, 54 degree, and then close your parenthesis. And then from there, just it's all from your calculator. So this gives us 63.21, and this is okay. Okay, and then for number 7. So for number 7, you have to draw your own right triangle. Right, so then a ladder needs to reach the second floor window, which is 10 feet above the ground, and make an angle with the ground 70 degrees. How far out from the building does the base of the ladder need to be positioned? So then in order to do number 7, it's easier if we make a little diagram. Right, so let's say this is our building. Okay, and it's saying that it's 10 feet above the ground, so we know that this is 10. And we are to lean a ladder to the building, and this is our ground. And it's saying that it's make the angle of 70 degrees, and we're going to find out how far is it from the building. So then this is your opposite, the ground is your adjacent. So then we can see that this is tangent of 70 degrees is equal to opposite over adjacent. So to solve it, we use the cross product. So then x equal to 10 divided by tangent of 70 degrees. And from there, just use your calculator. So 10 divided by tangent of 70 degrees. So this gives us 3.64, and this is in terms of feet. Right, okay, so here we want you guys to start trying to use your ratio. So identify the relationship in the figure to the right. So then for number 1, we're looking at tangent x. So then tangent x is here. So then they say from wx, so then this is opposite, so then would be vw, or if we're looking at the smaller triangle, so let me do that in green, so then would be the opposite would be yz over zx, right? Okay, and then for number 2, we're looking at angle V. So let me erase this. Right, so we're observing from this angle. So then this is your opposite, and that's your adjacent. So if we're looking at the larger angle, would be WX over VW, or we're looking at the smaller triangle, would be ZX over V over YZ. Okay, for number 3, this is something new that we haven't introduced yet. So when you see this, okay, this is called the tangent inverse, which is we're looking for the angle. So when this is called tangent of angle x. So here we're looking for the angle of the tangent. All right. So let me erase this part. Okay. So so then we're still using the same ratio. Tangent of an angle is always opposite over the adjacent. Right? So here we're looking at the inverse tangent VW over WX. So then we look at VW, so then this is the opposite, and WX, this is our adjacent. So then that means that we're looking from angle X. So then this is your angle X. Okay, let's try our next one. So then we look for number 4, tangent inverse of WX over VW. So WX, so that this becomes your opposite, and this is your adjacent. So then that means that we're looking from angle V. Okay. And then for number 5, we have tangent X times tangent V. So when we're given tangent X is VW over WX times tangent V, well, tangent V is WX over VW, and by the cross product, they will all reduce to 1. And then for number 6, well, let's go back to number 3. So here we're saying that tangent inverse VW over WX is the measurement of angle X plus, and this is referred to number 4, tangent inverse WX over VW is the measurement of tangent V. Well, since this is a right angle, that means that angle V plus angle X must be 90 degrees. Okay, so here's the part that we need you to use your calculator, right? Okay, and one more thing is that I keep on saying this is that make sure that your calculator is in degree mode in order for it to work. Right, so then for number 7, we want to find the measurement for the tangent of 23 degrees. So you just use your calculator, you type in tangent and the number 23. So this gives us 0.4245. Okay, and usually when we work with tangent, we always carry out to 4 decimal places. Number 8 to tangent of 43, so 0.9325, and tangent of 47 is 1.0724. Right. Okay, and for number 10, we're looking for the tangent inverse. Okay, so then in order to do the tangent inverse, you have to do the second or the shift key on your calculator. Right, so do second or shift key and then type in 0.14. So this gives us 7.96 and degree, and then do tangent inverse of 1. So this gives us 45 degrees. Right, and continue with your number 12. Okay, so here we're saying that tangent of something is equal to 0.4. Well, we have that already, so that means that this is tangent of 7.9696 degree. Right? It's similar to number 11. So then we see that the tangent of something equal to 1. Well, this is the same one, so that means that tangent of 45 degree is 1. And similarly here, so this is 80.69 degree. Right, so that's the end of our 18.1 day 1 notes. So your assignment is number 2 through 14 even, and number 18 in your book. And we have a new HRW, and you are to copy down 18.1 day 2 notes.